Now, nitrogen is 2, 5. So let's say the first one has 5 electrons. 1, 2, 3, 4, 5. And the other nitrogen has got 5 electrons. 2, 3, 4, 5. Now suppose we start by contributing this one. This one comes here, and this one also has contributed. Now if we count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We still need another contribution. Suppose this one is contributed, comes down here. And this one is also contributed, it comes down here. So we count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Still not enough. Then this one is contributed, comes here. Then this one is also contributed, comes here. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then that means for this one to be stable, this one has to contribute 3 electrons. 1, 2, 3. This one also has to contribute 3 electrons. 1, 2, 3. Now we can say how many covalent bonds do we have? And XO in ammonia, we have one, another one, then we have another one. So in other words, in making nitrogen gas, we are having 3 covalent bonds. We are having 3 covalent bonds, and that is shown there. That is shown there. And in the other one, you see in circle, the shared pair will be like this. And so the 2 will be here, the 2 will be here. Then the shared pair will be. So they will be shared in the middle. The part which is shared has to be in the middle there. Now, to the next example, we are going to talk about ammonia. Ammonia is a gas, and ammonia is written as NH3. That means we have 1 nitrogen and 3 hydrogen. 1, 2, 3. Now, remember, nitrogen has got 5 electrons. 1, 2, 3, 4, 5. While hydrogen has got only 1. 1, 2, 3, 4, 5. This one has got 1, 1, 1. Now, how do we make this one stable? The easiest type of covalent bond to deal with is where hydrogen is involved. Because just step 1, you give hydrogen here. Take that means this one will be gone. Take this one, give hydrogen, it means this one will be gone. Then take this one, hydrogen. So the 3 with your hand, let's see if it's balanced. 1, 2, around nitrogen now. You want to count the electron around nitrogen. 1, 2, 3, 4, 5, 6, 7, 8. For nitrogen, it's good to go. Then for hydrogen, has got 2, that's good to go. This one has got 2, this one has got 2. Then it's good to go. So there's another way you can write this. We have the first covalent bond here, the second covalent bond here, then the third covalent bond here. The only reason as to why these are not covalent bond because these are pair of electrons which doesn't have an XO. They are both dots. Doesn't have an XO. So these are 3 covalent bonds. 1, 2, 3 covalent bonds. Let's see. We have another example. Yes, carbon 4 oxide. Carbon 4 oxide is written as CO2. That means we have 1 carbon and 2 oxygen. CO2. Oxygen has got 1, 2, 3, 4, 5, 6. Carbon has got 1, 2, 3, 4. Then this 1, 2, 3, 4, 5, 6. Now we want to look at the sharing that will enable this one to have 8 electrons around it. This one has to have 8 electrons. This one has to have 8 electrons. Oxygen needs only 2 to be stable, while carbon needs 4, and hydroxygen here needs how many? 2. Now, this one, if suppose oxygen contributes 1 here, that means carbon will contribute 1. Coming to this part, oxygen contributes 1, then carbon contributes 1. Now, if we count around carbon, how many we have? 1, 2, 3, 4, 5, 6. Around oxygen, 1, 2, 3, 4, 5, 6, 7. Around this oxygen, 1, 2, 3, 4, 5, 6, 7. Still, none of them is balanced. Let's say oxygen contributes this one, then carbon contributes this one. Then all this oxygen contributes this one here, then this carbon contributes this one. Let's see. Around oxygen, 1, 2, 3, 4, 5, 6, 7, 8. That's it. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Now looking at that, we find that in carbon 4 oxide, then you have to have rearranging them. This will be have 1, this one, rearranging this part. Then XO. Then we have oxygen here. Then put them here, these 2 here. I'm just rearranging what we have here. Then for around this oxygen, we have already, this one is already presented. Then we have this one, here. So, looking at this, we write oxygen. How many covalent bonds do we have? 1 covalent bond, another covalent bond. C. This other side, we have 1 covalent bond, 1 covalent bond. So, that is how we do that. Now, I want us to do one which is not in the example. A methane gas. Methane sitting as CH4. That means we have 1 carbon here and 4 hydrogen. Now, hydrogen has got 1 here, 1 here, 1 here, 1 here. While oxygen, carbon has got 1, 2, 3, 4. Now, I told you any covalent bond involving hydrogen is the easiest. Just take 1 from here into hydrogen. Take 1 here. So put X here. Then take this one into hydrogen here. Then use this X, put it here. Then take this one into hydrogen. Then this X, put it here. Then take this one here into hydrogen. Now let's see. Hydrogen has to go to 2 up to in order to complete. Hydrogen has 2, hydrogen has 2, hydrogen has 2. Now let's see around carbon. 1, 2, 3, 4, 5, 6, 7, 8. So this thing that is covalent bond, and you have to do more and more practice for you to know how to come out with this bonding. So suppose now we want to use the dashes. We have hydrogen, 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 hydrogen. Now, when you reach from 3, you are going to see this dash being put here. So this one covalent bond XO, another XO here, another XO here, and another XO here. So you read from 3, doing organic chemistry, you will see methane written like this. But when that time comes, you will understand why it has to be written like this, but not just do things you don't understand the way it come out. Now that brings us to that bit, and there are more and more examples of what you can, more examples you can practice. You can go to your books and try practicing and see whether you are able to do that. Now let's talk about what we call coordinate bond. Coordinate bond is also called a relative bond. What's a coordinate bond? Coordinate bond is something I'm going to introduce. So that next time we are going to pick it from there. This is whereby, you see, in ionic bond, there was complete transfer of electrons. Complete transfer. In the covalent bond we just seen, there was what we call sharing of electrons from both parties. But in coordinate bond, you are going to find that only one pair or other element is going to give the pair of shared electrons. So when we reach there, we are going to understand what I really mean by that. So I think we should be having a good day as you digest what we just done. Thank you.